Better dropping fast.
Hello.
Very audible. You are audible.
Fine. Now please share your doubts.
Yes, sir. Generally, we will define momentum as product of mass and velocity.
Yes.
What is the actual meaning of momentum, sir?
Actual meaning of momentum is quantity of motion possessed by a body.
It's a vision
Okay.
quantity of
Like-
motion.
Yes. Actually, it is quantity of motion. Like a body is moving, how much motion it is possessing in itself. That is actually called a momentum. If its motion is larger, it will continue to be in motion. It means it is momentum. And if its motion is less, then it won't be continuing. Means we can easily change the direction. We need not to apply much more force. But if the mass is much larger, then we cannot do so. Motion is actually nothing but product of mass and velocity. This is called momentum, and it is the quantity of motion. By v equal to u plus at, s is equal to ut plus half at square, we are describing how motion is occurring. Means how the object is covering the displacement. How the object is moving, that's it. In what time it is covering how much distance. But what is the actual quantity of motion? Is there a quantity of motion? Yes. That quantity of motion is called momentum. Got it now? And mathematically, momentum is defined as product of mass and velocity. Got it?
Quantity of motion means it's how much speed or with how much velocity is moving, like that we need to assume.
See, like when we say when we say water, let us say water filled in your tank. Okay. Now in your tap, the tap which are connected in your homes, they are all connected with that water tank, is it not?
Yes, sir.
Just listen carefully. All the taps are connected with the water tank, which is at the topmost level of your house. Okay. Now, from that tap, water is coming at some speed, is it not?
Yes.
Water is coming at some speed? Yes, water is coming at some speed. So, generally, you are describing the speed of water. Now, speed of water is a different thing. Speed of water is a different thing, but how much water came out of the tap, that is different thing. For that, you need to measure the amount of water, is it not? In liters.
Yes.
Getting it? Getting it on?
Okay.
And that will be what? That will be velocity into area. Velocity into area. That much volume of water is coming out in 1 second, is it not?
Yes, sir.
What is velocity? Velocity is length upon time, is it not? So length
Okay.
multiplied by area will give you whole amount of volume. Okay, so this much volume coming out in 1 second, that will be quantity of water. So quantity of water is different thing, and amount of water is different thing. Amount of water is different thing, and velocity of water is different. Similarly, when we are analyzing the motion, so analyzing the motion means speed, in how much time, how much distance it is covering, it is different. It is like speed of water. So when you are analyzing speed of water, it is a different thing altogether. But when you are analyzing how much quantity of water is flowing, that is a different thing altogether. So motion, when we are defining it, it is actually speed. We are defining the speed. But when we are defining the amount of motion, quantity of motion, we call it as momentum. Mass into velocity. Got it now?
So we are comparing it with the amount of volume of water, amount of motion.
No, that's just an analogy. Please try to understand. That's just an analogy. I am saying that analogically, I am just saying that these two things are different, aren't they? The amount of water is a different thing altogether.
Well,
but the speed of water is a different thing. The speed of water is in motion, is it not? Water in motion. Water is coming out of tap with some speed. So water is under motion. But how much water came out, that depends upon the size of your tap. How much area of cross section your tap is having. That is a different thing altogether, is it not?
Yes, sir, and that's it.
Similarly, amount of motion is different thing. Amount of motion is called momentum. Here it is volume, and here amount of motion is called momentum. That's it.
Just amount it is.
Yes, it is the amount of what amount of motion is present. What amount of motion is there. Okay, I am just giving an analogy. Both are different things. Got it now?
Well, got it. So, in the kinematics, we consider every object as a particle to overcome the difficulties when complexity of motion of different objects.
Sorry, you are not audible properly. But
Sir, in a kinematics, we treat every object as a point object, particle.
Yes. V equal to U plus AT, S equal to UT plus half AT square, they all are nothing but point objects.
Yes, sir.
Masses, okay. Yes.
We consider them as point masses because to avoid the complexity of motion, we can say.
Yes, to avoid the complex, otherwise the motion will be very complex. Because every point of the body is having a separate mass, is it not? Actually, thing is, every point of the body is having separate mass. Little mass is there. And when we are multiplying full mass with some speed, then we are getting amount of motion. When we are multiplying full mass of the body. Okay? But when we are not multiplying, when we are not multiplying each and every particle's mass separately, it means we are assuming that the body is a point mass. All the mass is considered at a single point, and that single point is having a particular velocity. Okay. But this will be possible only when the particle or the object is having very small size with respect to the motion it covered.
So means even we can apply them for a large particles by after discovery of center of mass.
Yes, center of mass we can say that.
So means after this discovery of the center of mass, we are applying four kinematics and force equations for large bodies. Also consider them as a center. The whole mass is considered at the center of mass.
Sorry, you are not audible.
Sir, means
What did you say?
So we are after discover a center of mass, we assume that the whole mass of the body is at center of mass and applying all formulas to the center of mass in the kinematics and Newton.
Yes, fine.
Sir, in the mostly under vertical lines, under gravity. Generally, where the particles start, we should take that as the origin point.
Yes, hello, what did you say?
Where the
Motion under
particles,
gravity?
where the particle is starting, we should take that as the origin also.
Not necessarily. You can take origin at the ground also.
Depending upon the question, we can.
Yes, depending upon the question. It's easy. Most of the times, it is easier to take the origin at the starting point. Okay, but ultimately depends upon the question. Means it is not a law or something like that. We are just taking that at our ease. If it's easy, then we will take that, and if that will help us, then we will take that. Means ground level we will take as origin. Okay, like if in the question ultimate height from the ground is asked, then we can take origin on ground as well. Okay.
Fine, sir. Sir, I mean, sir, in the motion today we are discussing motion of the body in the projectile motion.
Motion of a body is projectile when?
Sir, motion of a body on an we'll discuss on an inclined plane. Motion of projectile on an inclined plane. Sir, that
Yes,
formulas we need to remember on one it.
No need to remember those formulas. Just remember one thing: whenever such question is there, just resolve each and everything into x and y component. If you can remember that, then the question you will be able to solve the question. Okay. Otherwise, because directly formula based question is very rare. Direct formula based question is very rare. So just try to remember the concept. Means break the velocity into x component and y component. Now what is the x-axis and y-axis here? Here x-axis and y-axis are also inclined. Okay, and on those inclined axis, we are taking the gravity, component of gravity and component of initial and final velocities, and then we will solve for each straight line separately. Then we will combine the result. This was the concept. Okay, so just remember the basic concept. You will be able to solve.
Just we need to remember the concept and we can solve.
Yes. Remember the concept, because each and every question, if you see the previous solved questions of previous year, IIT, JEE and all those questions, in those questions also, we were using concepts only. If you see the solutions, only concepts are used everywhere. Direct formula is rarely used because direct formula is not even applicable most of the times. Okay, so just use the concept. That's it. If concept is remembered, then it's fine.
Generally, from Newton's second law, we say that force is directly proportional to the index external force acting on the body directly proportional to the rate of change of momentum.
No, didn't get you.
So, from Newton's second, we say that the net external force acting on a particle is directly proportional to rate of change of momentum, no, sir?
Yes.
So then force will be equal to some constant into dp
Yes,
by dt.
that constant is experimentally found to be equal to 1. If you see in any book, wherever its derivation is given, actually constant is there, but experimentally that constant is found to be equal to 1.
So means how doing some experiments they found a constant as once.
Huh? How?
By doing experiments they found it constant as once.
Yes. See, momentum is already defined. Momentum is mass into velocity. Okay, and force is what? Mass into acceleration. Now, when they calculated the momentum, when they calculated the change in momentum divided by time, then it was exactly equal to mass into acceleration. It means the proportionality constant is 1 here. Got it? See, actually this thing is because such a thing is arising because momentum is a different thing and force is a different thing. We cannot equate both of them. So rate of change of momentum we took out, and then we said yes, it is proportional. Rate of change of momentum is proportional to force, or we can say force is proportional to rate of change of momentum. Okay, so that's why they first of all thought that they are little bit means some relation is there in between them. They are both proportional to each other. Whatever force we are applying, in proportion to that, change in momentum is occurring. Means change in momentum is directly proportional to the force applied. Got it? Change in momentum is directly proportional to the force applied. But when this change in momentum is divided by the time, it was found that whatever is coming out is exactly equal to mass into acceleration. It means the proportionality constant which we were using, that is equal to 1. That's it. So this is all experimental. Okay, just remember it. The proportionality constant is equal to 1 in this case. Fine.
Yes. So generally, so in the Newton's laws also we consider every body as a point of difference.
In Newton's laws of motion? No,
yes, sir.
No, it depends. It depends.
So means in the free body diagram, by considering it as particle only, we will draw mass.
A free body diagram, when we draw, we just locate the specific center of mass and on that we apply all the forces for just being symmetric. Okay, but we know that the object is having some boundaries.
So but up to center of mass, we consider every object as an and point of the tooliness.
Where?
Sir, in the kinematics and Newton's laws of motion, we always consider them as a point of the tooliness, sir. In the center of mass, they will start defining bodies, sir.
Yes.
Sir, but in the books also.
Actually thing is that concept of force and acceleration is applicable, means all the Newton's laws are applicable for point masses. Because if you are taking a rigid body and you are applying the force on somewhere else, the body will rotate definitely. Getting it? Why we are taking point mass in force? We are taking point mass because if it is not a point mass, if it is a rigid body of some shape and size, and you are applying force anywhere on the body, then the body must rotate also. Means whatever energy you are applying, that energy will convert into two energies, translatory energy and rotatory energy. This will be the problem. Then your calculation will be wrong. When you will say that I applied this much force and it must move with this much acceleration, but that acceleration you won't be able to find. Why? Because some part of that force is converting into angular acceleration. Body is rotating also now. Okay, it is not only moving with acceleration, it is rotating with acceleration. That's why we have to apply this, that the object is point mass. If even if it is a rigid body, yes, you can apply force, but that force must be on center of mass, so that the body will move without rotating. Okay, if the force is being applied on center of mass, then the body will translate without rotating. But if it is not a point mass, means we know that point mass is having only all of its mass concentrated at one point only. And if it is not a point mass, then the mass will be distributed throughout the body. And now when you apply the force, body will rotate. Now our calculation would be correct. Hence, we are assuming it to be point mass everywhere. This is the reason.
Means because here we are already discussing about the translation effects, which to avoid the
rotation. Yes, because otherwise, if you are not considering it, body must rotate. It will rotate, and definitely it will rotate. And now, if it is rotating and you applied some energy, that energy is not imparted fully. That energy will be converted into rotatory energy also. Means the object is not moving from one place to another. It is just rotating like a top at a single place.
Sir, other reason we can say as because we suddenly say that Newton's laws is applicable only at the point of the point particle.
Yeah, that's why we say that.
That's why we consider the whole body mass is supposed at the center of mass and
yes. So either center of mass we need, or we need point mass, which is automatically coinciding with the center of mass.
That's why we take the center of mass as.
Yes, this is the reason.
Sir, can you explain that method to solve Pulley constant?
Pulley, we need a full class for that. Right now I can't explain that, because for pulley you must be proficient with constrained motion. Concepts of pulley will be there in constrained motion. Constrained motion, you remember?
Yes, sir. The motion of one depends on another.
Three constraints are there in motion. Three pulley constraint, wedge constraint, and spring constraint. These three constraints are there. Okay. So
yes,
we study everything according to them. Okay.
Sir,
Yes.
Sir, Earth is not an inertial frame of reference.
Which one?
Yep.
Earth is not an inertial frame of reference. See, absolutely Earth is rotating.
And it has
absolutely Earth is rotating. And because Earth is rotating and it is performing revolution also at its own axis, hence we can say that Earth is accelerated. Fine, yes, it is accelerated. And hence it is not an inertial plane. But, there is a big but. Why? Why this but is there? Because for us, we humans are very, very, very tiny particles with respect to Earth. Okay, when you see Earth from space, even Mount Everest become just like a plane. Yes. Whole Earth looks like plane, no mountains and nothing is seen. So now then what we are? We are just very, 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 very tiny particles. And for such particles at that much level, so means we are like, on that perspective, we are at quantum level. Means like we are like molecules in this much system. For this system, for Earth revoluting and for Earth rotating on its own axis, Earth being accelerated, to feel the acceleration, it means like as if we are like molecules, because the size is enormous. Size of Earth is enormous, and its radius is again more enormous. Means light is also taking 8 minutes to reach from Sun to Earth. It is that much large distance, very large distance. Okay, and now whole diameter, and on whole of that diameter, Earth is just performing revolution in 365 days continuously. And now in mathematics we know some approximation that what is a straight line. A straight line is part of very small part of a very large circle, is it not?
Yes, sir.
Getting it?
Yes.
So when we are saying that a straight line is nothing but part of a very large circle, and we are studying in rectilinear motion, that rectilinear motion is inertial. It is an inertial frame because we are moving in a straight line. When we will move on circular motion, then it is non-inertial. So Earth, because Earth is very large, plus it is moving on a more larger orbit. So Earth itself is very large. Secondly, it is moving on a very large orbit. That's why we can consider it a straight line. That's why we can consider it a straight line motion. For us, it is a straight line motion. And because of its straight line motion, now no concept of centrifugal force, centripetal force is applicable. Means it is not an non-inertial frame. It is an inertial frame of reference. We can apply at our level. At our level, we can consider it inertial frame of reference. Why? Because we are very small, tiny particles with respect to the radius of rotation of Earth. Getting it?
And getting
Okay. So yes, definitely it is non-inertial frame owing to the definition, but owing to the approximation. Why we are taking the approximation? Because of size of Earth and size of the radius in which it is making revolution. That size of Earth is large, and then its radius is much more larger, very large. Because of that, a small part can be considered, definitely considered a small part as a straight line. And when that much part is considered a straight line, then what? Then we can call it non-accelerated motion. We can assume that it is moving constantly in a straight line. We can assume that. Okay.
means moving with constant acceleration.
No acceleration is there. Constant velocity is there.
Okay, constant acceleration. Constant.
That acceleration is very small for us, very feeble for us, because radius is too much large. Okay, so mv square by r, we are dividing it by radius. We are dividing it by radius. And radius is radius of revolution of Earth, remember it. Radius of revolution of Earth is much larger than the diameter of Earth. Getting it? So mv square by r will be very feeble.
Sir, point mass means the smallest mass you can have.
The smallest mass, no. There is nothing like a smallest mass. Like, can you say smallest water? What is this smallest water? What is a small water? What is a small air? Okay, water is just name of an element. So a small water is nothing. Okay, you must define water with the quantity. Getting it? So mass is just name of the quantity. Mass is just the measurement of inertia. Okay. A small mass, what will you call a small mass? 1 kilogram or 100 kilogram? Which one is a small mass? 1 kilogram is a small mass. But both can be point masses in case of physics. 100 kilogram is also can be point mass, and this 1 kilogram can also be a point mass. Even whole earth can be considered as a point mass in physics. Okay, so point mass concept is different, and it cannot be called a small mass, a smallest mass. Okay, definition will be changing. Means wrong things you are comparing. Like one man is saying juice of banana. But juice of banana is not possible. It's called shake. There is a reason we call it as shake, because that is different. It is not called juice. Similarly, we cannot call a small amount of a small mass. Means in which perspective you are saying a small mass? 1 kilogram, 2 kilogram, 10 kilogram.
How much we are saying that
or size. Or size you are saying. And if you are saying size, then all of them. Size is a relative quantity. Size is a relative quantity relative to the distance under consideration. If the distance under consideration is very, very large than the size of object, then it can be considered as point mass. Like whole earth can be considered as point mass when we are dealing with the gravitational forces. Okay, when we are considering the rotation of earth with respect to sun, then we can consider earth and all the planets as point masses. Okay, when we are dealing with the gravitation, because radius is much, much larger than their size. Okay, so 10 kg, 3 kg, 200 kg, 500 kg, all of them can be point masses. All of them can be point masses. Just remember one. So you should not call them small. Just remember that all of them can be point masses if the relative distance under consideration is much larger. That's it. Just remember this.
So in an NLM we can consider considering bodies as point masses because here we are only as a center of mass point because we are only considering the translation effect of forces.
Yes. That's why we are considering them as point masses. We are considering all the masses situated at single point. Okay, this is the reason. Here the reason of considering point mass is different. Here the reason of considering point mass is calculation purpose. While generally in physics, when we consider point mass, when the object under consideration is smaller with respect to distance or relative distance under consideration. Okay.
I mean, whenever we say force is applied on a body, it's applied on the center of mass differential.
I didn't hear you. What are you saying?
So whenever we say that if any force is acting on a body, sir, in the NLM, we should assume that it is active on the center of mass, sir.
Yes.
So gravitational force field is just a force due to attraction force on the body due to Earth, sir.
Yes, the gravitational force can only be attractive. It cannot be repulsive force.
I mean, this force is due to the Earth, sir.
Gravity is due to Earth. Gravitation is applicable on all the objects. All the objects which are having mass.
Sir, so what is the source of this gravitation?
Mass is only the source of gravitational force. Means whenever mass is there, then gravitation force is there. Now, actually, we are unable to know why these gravitational waves are originating. Means, are they originating from proton, or proton plus neutron, or proton plus neutron plus electrons? What is happening at that much quantum level? We cannot define gravitation. We cannot define gravitation at that much quantum level. We have not seen its source, and now one more theory is coming out, string theory it is, and it says that the existence of gravitational waves, like electromagnetic waves are there. So similarly they are proposing gravitational waves. But that is the one thing which is not proven yet, and we are still researching about it, that how this gravity is produced. Till now, what we know is that gravity is being produced because of mass. If mass is there, then it will attract another mass. That's it, and this is called gravitational force. When one of the object is Earth, then it is called gravity. That's it.
Sir, means here.
Yes?
Just now, up to now, we can say just mass is the source, but atomic level we don't know exactly.
Yes, atomic level we do not know.
Then what is this effect of this electrostatic force? Electromagnetic.
Electromagnetic forces are appearing due to the charges. They are appearing due to charges. See, fundamental forces, if you just look for the fundamental forces, there are 4 types of fundamental forces we humans have encountered yet. Weakest of them means that at gross level, weakest of them is gravitational force. And then comes electromagnetic force. Electromagnetic force comprises the forces between the charges and the forces which are produced because of charges, like magnetism is there. Magnetism is producing because of the flow of charges or arrangement of the charges in a particular pattern. That's it. Similarly, when electrons are arranged in a particular pattern, we can see these electrostatic forces if electrons are transferred, and when they are arranged in a particular pattern, we can see magnetic forces. So combined, it is called electromagnetism. So electromagnetic forces are the second powerful forces, means they can encounter gravity also. They are much more powerful than gravitational forces. Gravitational forces are appearing due to mass only. Mass which is consisting of electrons, protons. Now when these electrons and protons are combining, they are attracting other masses. This is called gravitation. When we separate electrons and protons, they are still attracting. It is called electromagnetic forces. Okay? And when we are getting inside the nucleus, we are getting nuclear forces, the strongest forces we have encountered yet. That is nuclear forces. And third is weak nuclear forces. That is something else. Means weak nuclear forces are so much small, they are appearing inside a proton. This proton is emitting one positron, and becoming a neutron. Okay, so the force with which proton is emitting positron, it is called weak nuclear force. It is weak as, but it is not seen on gross level, means bulk level it is not seen. On bulk level, whatever forces we are able to see are electromagnetic forces and gravitational forces. Gravitational forces are very weak and we are not able to see them. Okay, like between two human bodies also gravitational force is acting, but it is so feeble, so small that the force with which we are inhaling and exhaling the air, that force is greater than the gravitational force attracting between two human bodies. Okay, getting it now?
Yes, sir.
So, gravitational force is due to mass, electromagnetic force is due to charges, nuclear forces are due to distance between two protons and neutrons, and weak nuclear forces are inside a proton and a neutron. That's it.
So, sir,
Well, yes.
sir, we do not consider gravitational forces and electrostatic forces in the free body diagrams because that gravitational force is very small and
No, who said that? MC we are considering or not?
So I'm not saying about gravitation, sir. I'm saying between the two bodies.
Mutual gravitational force you are saying?
Yes, sir.
See,
between two bodies. Right?
Yes, we do not consider. Why? Because air is present between them, and that air resistance is much more greater than this gravitational force, which is acting between two of them. Okay, air is between them or not? So air offers some resistance. Air offers resistance. We know that feather falls very slowly because air is offering resistance. So that air resistance is much greater than this gravitational force. That's
so
why
when
you are neglecting air resistance, then there is no need to use that gravitational force. Are you neglecting air resistance or not? First of all, tell me that. Yes, you are neglecting air resistance. Even we are neglecting. See, like I am saying, what is the weight of your body? So you will stand on a weighing scale and you will isolate yourself. You will draw free body diagram. But are you inhaling or exhaling? Yes, you are inhaling and exhaling continuously. We are breathing, aren't we?
Yes.
And the force of breathing we are not considering. Are you considering the force of breathing? No. Why? Negligible it is. So try to understand that gravitational force is much more lesser than this force of inhaling and exhaling. It is much more smaller than that. It means negligible.
Whenever Earth is considered due to its bigger mass, we consider gravity, weight of the body, so gravity.
Yes. It is applicable only for the celestial objects. Gravitational force is applicable only for the celestial objects. Celestial objects means what? Earth, Mars, Venus, Moon, Saturn, Jupiter, Sun, stars, galaxies. These are to be considered when gravity is considered. Gravity we are talking about. Now, one more force is there nowadays, which is discussed on every platform, that is black holes. We do not know much about them, but whatever it is, we can, because it is a bulk body and it is a celestial body, that's why we are naming it as gravitational force. And we are saying that gravity of that star or dead star, whatever it is that much high that even light is not coming back. And actually it is not so that light is not coming back or it is absorbing the light. Actually it is not absorbing the light, it is changing the dimensions of time and space. It is that much heavier, it is changing the dimensions of time and space. And because of that, light is getting curved.
Yes.
This is happening. In black hole, light is actually getting curved. am I audible?
Say periodical service.
Yes. So this force of black hole is not understood yet. We are unable to understand that because obviously we cannot go there. But still we are calling it as gravity. Yes, is the screen visible?
Sir, it is visible. Sir,
It is said that whenever, like, space and time is like a mesh. It is like a mesh. And on this mesh, whenever we are keeping a heavy object, then you must have seen a blanket. Okay, blanket is generally straight, but when you are putting a heavy ball on the blanket or the sheet, it will curve it down, is it not? So similarly, because of black hole, the space-time is curved to that much point that when the light is incident like this, light gets curved because space-time is curved. So light comes like this. Light coming from here, it will go like this. Light coming from here, it will go like this. Means particularly U-turn this thing. So it is not absorbing light, it is turning the path of light. Light is unable to reach it because space-time is different. And light always prefers the smallest path. So it is following its space-time. So at that point, space and time are changed. Hence we can say that it is out of our world. The dimensions in which we are right now, that is out of our world. So this is just for interest purpose and it has nothing to do with our syllabus.
yes. Sir, sir, why we generally in a NLM we will not consider the electromagnetic forces, sir, due to charges? Means due to the neutrality of the body, the old will get cancelled. Sir.
Just a minute.
Yes.
Yes, now, yeah. What did you say?
Sir, we are not considering the electrostatic forces, magnetic forces between bodies, no, sir, in reality. Because that due to the neutrality of the whole body, the total force will get cancelled, sir.
No, not like that. Electrostatic forces are dependent on field. If the field is present, then we cannot neglect them.
Then why we are not considering them in the Newton laws in any way?
Hello, yeah, because field is not there. Hello. When field is not there, then there will be no force. If electric field is there, only then electric force will be.
Means due to the neutrality of body only we can say.
Yes.
Sir, this contact force, this all generated due to the how this tension in a spring is generating, sir, and the friction, how on the normal axis, how actually they are generating in a body.
See, one molecule is pulling another molecule.
So means atomic level, sir, the one molecule. That is
See, bonding is there or not? Bonding is because of electrons only. Electrons are going on that side, and that's why bond is formed. Okay.
Sir, means here sir, means in the atomic level, so when a body is placed on a surface, then the full load exerts that a force called normal force on the surface of the body, na, sir. Means we need to assume that the atoms at the contact surface due to some interactions, it is exerting a force called normal action on the body. That is the reason we need to assume. So there is no any particular.
No, not actually, not atoms. Actually, they are electrons which are repelling other electrons. Not even atoms. Electrons repelling other electrons. That is happening whenever we are talking about normal force. Like you punched the wall. Now what happened? When you punched the wall or you kicked the wall, the electrons of which are present on the last orbital of your hand, atoms of your hand, those electrons are repelling the electrons of wall. And on the bulk level, you are seeing that you are punching the wall. Actually, electrons of your hand and electrons of wall are striking together. And what is happening? They are just repelling each other. That's it. Got it now?
That means due to that repulsion, this force is generating.
Yeah, due to repulsion, this force. Yes, yes. So ultimately, normal reaction is what? Electromagnetic. Similarly, electrons of molecules are bound together. In between the molecules, they are intervened. Because of this, what is happening? When you are pulling the rope, the molecule is getting pulled. All the bonds are getting pulled. Hence, you are able to apply tension through the rope. Okay, this is the tension. So, tension is also electromagnetic in nature. Because of bonding due to electrons, this force is occurring. Similarly, spring force. In spring also, the arrangement of electrons and atoms are trying to retain their position. That's why spring is able to repel. Means spring is able to regain its position. Because the electrons and atoms, they want to retain their original structure. That's why it is happening. So it is also ultimately electromagnetic force. All the bulk forces, friction is there, see. In friction, what is happening? Again, whenever we are touching an object, some electrons from our hand are jumping into the other object, and some electrons from that object are jumping in our hand. Now, some bond is formed. Very, very weak bonds are formed now. Now, these weak bonds will require energy to break. Hence, the object will require energy to move. Okay, this is called friction. Another one is interlocking. The molecular structure interlocks within one another. And when you are pushing something, some object, what is happening? These interlocked bonds, they must be broken now. Hence, friction is generated. So, ultimately, it is also electromagnetic force. All the bulk forces, pushing, pulling, mechanical forces, all of them, they are electromagnetic ones. Ultimately, charge is considered. Ultimately, charge is present, and because of that, these forces are given. Okay? Got it now?
Sir, means all these normal force, contact force, friction, tension, all are electromagnetic force or contact force, we can say.
Yes. All are electromagnetic forces and all are contact forces. can say that.
Sir, but contact forces two types again friction and normal reaction. No, sir.
Contact force is friction, normal reaction. Tension is also contact force. Spring force is also contact force. Friction is also contact force. All of them are contact force only.
So all these forces which are generating because of contact are known as contact forces. Sir?
Yes. Yes. All of them are contact forces.
All these are generating due to the interaction between the atoms or electrons and protons, we can say. No, sir.
Yes.
We don't know the exact real effect of that, sir. Why
Effect
they
of
are
what?
generated? We don't know the real reason why they are generated like that.
No, see, real reason we don't know. We just know that yes, this is happening. We do not know the reason. In physics, we are understanding that bird is flying. How bird is flying? This is we are considering in physics. We are not considered with why bird is flying. Okay, it is. There can be several answers for that because bird cannot do any other thing. It is made to fly. It has got no legs, so it cannot walk. It can only fly. That's why bird is flying. Or it might be hungry. Bird might be hungry. Bird might be going for fetching some grain or some food. We don't know that. In physics, we are just concerned with how things are happening. Why they are happening, that is not our point of consideration. God has made them this way. That's it. For me, that's for me to say that God has made these things such a way and such a perfect mathematical combination that we are able to study them. That's it. Okay. Why this is happening? This is out of our scope.
Sir, in the Newton's laws, we are taking the approximation of particle at center, assuming it as center of mass point.
Yes.
Sir, whenever you given that if force is acting on a body, then it means that it's acting on the center of mass.
Yes. Unless it is specified that on which location the force is applied. If it is not specified, then we will take that the force is on the center of mass. Okay?
In the books they given that, sir, the behavior of all the point objects greater than 10 power minus 6 meters will be discussed in the classical physics, sir. How can a point object can have a someone is saying that every object length greater than 10 power minus 6 is a point object. There cannot be a point object.
No. You are getting it wrong. Point object is that, see, it is a relative term. Just remember that it is a relative term. Relative, you understand?
So means
like train is there. See, let us clear this. If a train is there, how much long is what will be the length of a train? It will not be more than 1 kilometer or so. When the train is moving from Delhi to let us say Tirunanthapuram, Trivandrum. From Delhi to Trivandrum, it's such a huge distance that we can consider whole train as a point object because it is thousands of kilometers. So in front of thousands of kilometers, 1 kilometer is point mass. Size of 1 kilometer will be considered point mass in front of 1000. Got it now? In front of even 100, we can consider it as a point mass. Got it?
Yes, sir.
Getting it?
Sir, yes.
So it is relative term. Train is covering larger distance, hence it is a point mass. But when train and a bicycle is considered, or train or a small animal is considered, a small animal which train is striking off, or a small car which collided with the train, then car and train both cannot be point masses. Then train will be heavier and car will become a point mass. When the train will strike the animal or a bicycle, nobody sitting inside the train will feel the jerk. Why? Because car or just that small bicycle or any animal, mass of all of them is very, very, very smaller than that of train. Okay, so again, it is all relative. It's all relative terminology, okay? So, with respect to something larger, we can consider it to be point mass, that's it. Okay, Hemant, now we shall continue tomorrow. I have to go now. Tomorrow, if you wish, we can continue with the constrained motion.
Yes, sir, we will do it.
Fine. Okay, then thank you. That's all for today.
Yes, sir.